In the yesterday's session, we had learned the preparation of amines and their physical properties. That is, when we go to the point like boiling point, that comes under the physical properties. In our today's session, we will be learning and recalling about the chemical properties. Yes, what topic are we going to learn about? We are going to consider the chemical properties of the amines. So once you remember the chemical properties, in these chemical properties, the first and foremost chemical property that we come across is basic nature or basicity. They will say basic nature or the basicity. On this basic nature only, most of the questions will be given according to the textbook. Once you see, they had brought in a simple content like how to study the basic nature in the gaseous phase and how is the basic nature of this amines in the aqueous phase. So let us go to the textbook first, then we can divide our concept. So what I am dividing is the basic nature in the gaseous phase. Basic nature in the gaseous phase. Generally, we know whenever an NH2 group is bonded to some alkyl group, it is called as a primary amine. Is it not, children? Good. This R stands for the alkyl group. R stands for the alkyl group. Maybe methyl or like ethyl. Methyl or like ethyl. What do these methyl or ethyl have in general? They have the property to donate the electrons through the sigma bonding. Has the show which effect? Plus I effect. Already on this nitrogen or lone pair is there, but due to the presence of the plus I effect from the methyl group, their basic nature will be increasing. Means alkyl amines basic nature is more. Whose basic nature is more? Alkyl amines basic nature is more than. We need to compare its basic nature with ammonia. If you see in ammonia, ammonia formula is NH3. So here itself nitrogen must be donated the lone pair. No other supporting group is there for this. So what we say, alkyl amines are more basic than ammonia. Okay, good. Now we have studied up the primary amine. But what we know in case of secondary amine, means, in case of secondary amine, we have two alkyl groups. This basic nature of secondary amine will be more than the primary amine in the gaseous phase. Please note down. Whereas in case of tertiary amine, the number of alkyl groups increases. Hence plus I effect will increase. So tertiary amine is more basic than secondary amine. It is more basic than primary amine only in the gaseous phase. But in their aqueous phase. Now I don't want to give you the whole story again. Simply I would like to conclude like in their aqueous state, in their aqueous phase, there are two problems that they are facing. One is called as the solvation effect. Solvation effect means the solubility in the presence of water. And second thing, due to the steric factor. How is the basic nature given means? It is given again in two methods based upon the substituent on the amine. For example, if you are having only methyl amine, dimethyl amine is more basic than methyl amine. Dimethyl amine is more basic than methyl amine, which is more basic than trimethyl amine, that is more basic than ammonia. It is in the case of methyl groups. How about if ethyl groups? C2H5 means ethyl amine is more basic than trimethyl amine. That that is more basic than methylamine, and that is more basic than ammonia, and that is more basic than ammonia. See, the solvation factor and steering factor we had learned in detail in the classroom section. It will take useless of time. So here we are able to conclude now once again that alkylamines are more basic than ammonia. Alkylamines are more basic than ammonia. It may be in the gaseous phase or it may be in the aqueous phase. Now let us go through the alkyl amines we had learned now, aryl amines. Let us see now with the aryl amines. So our concept is presently, let us speak, we have learned under the basic nature regarding the alkyl amines. Up to now we have learned about the alkyl amines. Let us see regarding the basic nature in the aryl amines. Basic nature in the aryl amines. How about the aryl amines? Are they more basic than ammonia or are they less basic than ammonia? Let us consider here. So aryl amines means what? Aryl amines means what, children? Aryl amines means, in the case of this aryl amine, the hydrogen is displaced and there one benzene ring is substituted. In this case, the lone pairs are in conjugation with the benzene ring. Lone pairs are in conjugation with the benzene ring. Hence, the lone pairs are not readily available to be donated. But in case of ammonia, they were freely available. So what we speak, aryl amines are less basic than ammonia. 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 By this we can bring one conclusion. Alkyl amines are more basic than ammonia, and ammonia is more basic than aryl amine. Ammonia is more basic than aryl amine. So this is one conclusion we can bring. But now we are studying in detail again in this aryl amines. If you find the substituted aryl amines, how is their basic nature? Means if an aryl amine is having some electron donating group. Now this electron donating group will give electrons to the benzene ring. In return they will be involved in resonance, and finally the electrons will be coming to the nitrogen to be donated for the Lewis acid whatever is approaching. So in case of electron donating groups, lone pairs can be donated. But in case of this electron donating group, once you speak, where is this located? This is located at the para portion. Electron donating groups that are present at ortho position, does not show more basic nature than para. The electron donating groups that are present at the ortho position are less basic than para due to steric factor. Which factor? Steric factor. Means what? Here bulky groups will be there. There will be some repulsions between the electrons and the molecule will be unstable. So even the electron donating group is present at the ortho position, it is less basic than para due to the steric factor. Secondly, if the electron donating group is present on the meta position, there will not be any effect. Means we speak, it is less basic than the ortho, and this is less basic than anything. Done, children? So this is how we can bring up how the electron donating group position affects the basic nature. Now we need to know what are some of the examples for this electron donating groups. Most of the examples we come across with methoxy, or we can come across with CH2, means methyl group, means with the methyl group. So these are the two of them that we can take as the best examples for the electron donating groups. But coming to the electron withdrawing groups, how about the electron withdrawing groups? And shall we take some arrangement of examples regarding the electron donating groups? Then we will go for the electron withdrawing groups. Coming for some examples regarding this topic, we know the methoxy and methyl groups we got now. So if you have the methoxy at para, it is more basic than methoxy at the orgo. More basic than methoxy at the orgo. And that is more basic than methoxy at the meta. Methoxy at the meta. Methoxy at the meta. That is more basic than aniline. That is more basic than aniline. Right? So one example, order we brought. For the second example, in the place of OCH3, you can place as the methyl. You can place as the methyl. I hope you understood. Good. Now let us see here. What is the effect of electron withdrawing groups? So this is the substituted effect in which we can find the electron donating groups. Here which effects comes in play? Resonance effect. Which effects will play? Resonance effect. Inductive effect also will be applying. Coming from the electron withdrawing group, they will show minus R. Electron withdrawing groups will show minus R. Any other group like NO2 means nitro group, or COOH carboxylic group, or chlorine. These are all will be examples for the electron withdrawing groups. If you observe any electron withdrawing group, what the electron withdrawing group will do? If it is nitro group, it will take out the electrons from the benzene ring. So the lone pairs must be involved in the conjugation, that will be involved in the resonance. Means lone pairs are not readily available. Means its basic nature is decreasing. So when an electron withdrawing group is present at the para position, the basic nature of the aniline decreases. Means what we can speak, it is going to be less basic than aniline. Means aniline is more basic than the compound that is having electron withdrawing group. And coming to the ortho position, if the electron withdrawing group is present at the ortho position, that is less basic than para position. Meta does not have any effect. It will not withdraw the electrons from meta group. So we speak that meta substituted aniline is more basic than para, and that is more basic than para orgo. Don't forget this order. Clear, children? This is very important order. Now we have seen how about the basic nature in the case of aryl amines, and we also explained in detail how about the effect of electron donating group and how about the order of electron withdrawing group. But in this word alkyl aryl amines, we are going to include one more word. What that one more word means? If you see any compound like this two, NH2 and CH3, NH2 and the CH3, and one more compound I am bringing, CH2 NH2. What is this one called as the aryl amine only? Methyl is substitution at the ortho position, but here it is called as the aryl alkyl amine or benzyl amine. Correct UPSC name is the benzyl amine. Now let us point out here, when the benzene ring is attached to the nitrogen, compulsorily lone pairs will be in resonance with the benzene ring. But But here the nitrogen is not bonded to benzene. So its lone pairs are not involved in resonance with the benzene. Means its lone pairs are readily available for the donation. Because again it is bonded to some methyl group. This methyl group will show which effect? Plus psi effect. Means that makes that nitrogen to donate the electrons. So keep in mind, if you compare aryl amine with an aryl alkyl amine, very important point. If you compare the basic nature of an aryl amine and the aryl alkyl amine, the basic nature of aryl alkyl amine is more than the aryl amine, because in this that is involved in the resonance, whereas the lone pairs are not involved in the resonance with the benzene. That is a simple point to be understood. Secondly, we brought all these points. One more point. Whenever a nitrogen is present within the ring, like heterocyclic compounds. Which compounds you have? Heterocyclic compounds. Do you know heterocyclic compounds? What are heterocyclic compounds? Can you please say what are heterocyclic compounds? Wherever the ring contains the nitrogen, like these examples. Do you remember in first year? Pyrrole. What did we call this as the pyrrole? And pyridine. What did we call this as the? We call this one as the pyridine. Now compare these two structures. In this, on the nitrogen or lone pair will be present. And if you study the lone pair, that will be involved in resonance. That will be involved in the resonance. Means see here, it may come here, pi bond will move here. So your pi bond is present here, it is present, and compulsory when it is coming, this negative charge will be falling on, the pi bond will be falling in another direction. Means the resonating structures, the resonance once we see, the resonance once we see means alternative movement of electrons, alternative movement of electrons, that is nothing but resonance. Whenever the resonance is present, electrons will be revolving within the ring, and the lone pairs are not available for the donation. Means what we speak, whenever there is a resonance, alternatively movement of electrons takes place, electrons are not freely available. But in this case of pyridine, you can observe here on the nitrogen lone pairs are there. Lone pairs are there. And beside the lone pairs, wherever you get a pi bond, within the ring you will think alternative resonance is there. But wherever beside the lone pair there is a pi bond, this type of structures will be more basic because it is a nucleophilic center. Pi bond is a nucleophilic center, and that will make the lone pairs to be readily donated. And in this you will not observe any resonance. So wherever there is no resonance, means alternative movement of electrons is not there. The lone pairs of nitrogens are freely available. Hence, what we say, these are more basic. Which are more basic? The structures where there is no resonance, they are more basic than the structures where you will find the resonating structures. Very important point. That's not there in the NCERT for us. One more. If you compare, now which is more basic among these two? Among pyridine and pyrrole? We can say pyridine. Why pyridine is more basic? It is not involved in resonance, and the two on the nitrogen lone pairs will be present. Wherever nitrogen lone pairs beside the pi bond is present, it is more basic. When you compare the cyclic compounds, cyclic like heterocyclic, I would like to call this one as a heterocyclic, and the alkyl amines, Now generally what we know, I'm having one heterocyclic compound. Heterocyclic compound. In this 5 bonds are not there. Okay. Now, which among these two will be more basic? Which among these two will be more basic? You can see here the nitrogen is bonded to 2 other carbons. This is a secondary nitrogen. This is also a secondary nitrogen because the nitrogen is having 2 alkyl groups. Point to be remembered is heterocyclic nitrogen containing compounds. Heterocyclic nitrogen containing compounds are more basic than the alkyl amines. Heterocyclic compounds containing heterocyclic nitrogen containing compounds are more basic than the alkyl amines. So these are all the additional points that we discussed beyond the NCERT. Let us see some questions here, then we will continue regarding the remaining chemical properties after seeing some of the questions. Let us see this question, children. Some questions I am getting from the previous years. One of the questions you can directly attempt this question. The question is the order of basic strength of methyl substituted amines in aqueous solution is. You know, take the correct without seeing the options also you can blindly get it. In the methyl groups, whenever you have secondary methyl amine is most basic than primary methylamine, that is more basic than tertiary methylamine, and that is more basic than ammonia. That is the order. You find out the correct option in this. You read the options, so you can take the screenshots. I don't want to waste my time reading the. Go for the question number next followed by. The correct order of basic strength in the following is. Correct order of basic strength in the following is. Some structures they are given. First structure once you have seen, for the benzene we have NH, for that there is the CH3 group. And second structure they are given like NH2 is there on the benzene, and in the para position we have OCH3 group. Third structure we have the CH2 bonded directly to the benzene, for the CH2 NH2 is present. And the fourth structure if you see, we have NH2 on the benzene ring. Now compare. What we had learned, aryl alkylamines are more basic than the aryl amines. Is it not, children? In this, which one is the aryl alkylamine? Aryl alkylamine. In this aryl alkylamine, lone pairs are not involved in conjugation with the benzene ring. In the remaining 3 cases, if you see, the lone pairs are involved in conjugation with the benzene ring. Here also lone pairs are involved in conjugation with the benzene ring, and here also lone pairs are involved in conjugation with the benzene ring. So what happens? The first and foremost thing we can find out, third one will be more basic than the remaining 3. So in the given 4 options, first you search third must be greater than all the options. So we can see in the option A we got the third at the top priority, B we don't have the 3, and C we have the 3 in the top priority, D also we have 3 in the top priority. Now our next option is which will be the least basic. First you find which is the more basic, then you find which is the least basic. Here these are all alkyl amines, option 1, 2 or 4. Once you see 3 is not, it is an aryl alkyl amine. Once you see the option 1 and 2, this is an alkyl amine, this is also alkyl amine, this is only aniline. In this case of aniline, there is no donating group. But here we have a donating group at para position, one of the donating group is directly bonded to the nitrogen. So in these two, basic nature will be more. But in case of aniline, basic nature will be the least. So we need a set of given options. First you are prioritized to find out which is the top one and which is the least one. You can obviously get the answer. Then which is your correct answer? Top priority is aryl alkyl amine. That's option 3. And least priority is option 4 because it does not have any donating groups. So 3 is the starting, 4 at the least. Find out. Now you are in a dilemma to find two options, option C and option D. Now your priority goes among these two, which is more basic. Yes, right. The compounds in which, once we see, the methyl groups are bonded to nitrogen. It is called as alkyl aryl amine. Okay, alkyl aryl amine compounds, what they are called as the alkyl aryl amine. What is the name we had given previously? Aryl alkyl amine. Aryl alkyl amine. This is called alkyl aryl amines. Alkyl aryl amines are less basic than aryl amines. Alkyl aryl amines are less basic than the aryl amines. So this is an aryl amine, this is an alkyl aryl amine. Hence, what we can bring after the 3, next priority will be compulsorily 2. Next priority will be compulsorily 2. After that, we have the first one, the least one is the 4th. Once you read out the concept, recall it, it will be clear for you. You can see the next question here. The question number 3 we have the correct increasing order of basic strength for the following compounds. Option 1 once you see aniline was given, and option 2 we have nitro group for the aniline at the para portion. Option 3 we have CH3 group at the para portion. Now you must segregate here. This is having electron withdrawing group, whereas this is having electron donating group. What we know already, the electron donating group containing aryl amines are more basic. Aryl amines are more basic than the aryl amine. Which is more basic than the electron withdrawing group aryl amine. So find out the correct option. Electron donating group means 3 is more basic. So there is an increasing order. So you can obviously get it here. The option C we have the 3. It is more basic than the one which is more basic than the 2. So this is what the order we had. Very simple type of questions. Next, question number 4. What is the correct order of basicity among the following compounds? Names are not necessary for you. CH3, C, double bond N, NH2. CH3, CH2, NH2. CH3 twice, NH. And CH3 is double bonded O, NH2. So they brought some order. What is the character of basis among the following? Means the decreasing symbol is mentioned now. This less than symbol means the last one will be the least basic. Whatever this one is there, that will be the least basic. But in this type of questions, you can see all the A, B, C options they had given 4. Why they had given 4? The acetyl group, once you study, the carbon is positive in nature. Hence, that it acts as an electron withdrawing group. So, by the starting itself, they had given electron withdrawing group is present. Hence, its basic nature is less. Now, we have 3 options, 1, 2 and 3. Among these 3, which is the top priority? Already we brought one point. Whenever the nitrogen is bonded to a double bond, and the double bond will favor the lone pairs to be readily donated. Double bond will be favoring the lone pairs to be readily donated than the single bond. In the case of 1, there is a double bond of nitrogen along this lone pair. In case of option 2, we have a primary amine where the nitrogen is bonded to only one alkyl group. Here the nitrogen is bonded to 2 of the alkyl groups. So among these 2, once we see, when there are 2 alkyl groups, which that are like represented in this method, CH3, NH, CH3. This is obviously more basic than the CH3, CH2, NH2. more basic than the CH3CH2 NH2 because 2 methyl groups will show 2 of the plus effects. Than these two, what we already brought, wherever nitrogen is having a double bond, it will be more basic. So one is more basic than these two. So how I can bring this order? One is more basic than the 3, that is more basic than the 2, and that is more basic than the 4. This will be your order. Find out the correct order of this one. 1 greater than 3, that is greater than 2, and that is greater than the 4. Option D. Got it, children? Let us write down. We will go for the another bit. In case of substituted aniline, the group which decreases the basic strength is, in case of substituted aniline means already aniline we know. For this aniline, if OCH3 is present somewhere, what is the nature of OCH3? This is an electron donating group. Electron donating groups will increase the basic nature. But they are asking which decreases the basic nature. If we go for the option B, CH3. CH3 is also an electron donating group. And what is the one more we have? NH2. Already we know the nature of nitrogen wherever lone pairs are present. If at all NH2 is present, one more NH2 is present, this will give electrons to the benzene, is it not? So that is also an electron donating group. But if there is a phenyl, the phenyl or the benzene, it's an electron withdrawing group because it is having sp2 hybridizer carbon. So wherever phenyl group is present, that acts as an electron withdrawing group. When electron withdrawing group is present, basic nature decreases. Going for the next question. The increasing order of basic strength for the following aqueous phase. Increasing order means they have given some 4 options for us. For the first option, we know they are given as the aniline. We know electron aniline, very good. Second thing is triethyl amine. Now among aniline and ammonia, because option 4 is also there on here. Option 4 is there. Among aniline and ammonia, which is more basic, children? Among aniline and ammonia, we know ammonia is more basic. Because in this the electrons are involved in the conjugation. Now, greater than ammonia. We have one more option, triphenylamine. Means what? One nitrogen is bonded to 3 of the benzene rings. If you observe clearly the point that we had learned in the previous bit, the phenyl group is an electron withdrawing group. So in all these 3 will act like an electron withdrawing group. They will decrease the electron density on nitrogen. So the triphenylamine acts as an electron withdrawing group. So this electron withdrawing group triphenylamine is least basic than aniline, which is less basic than ammonia, whereas it is more basic, or we can speak triethylamine. Why we are using here triethylamine? Because this is an alkyl amine. So alkyl amines are more basic than ammonia, which are more basic than aryl amines. Alkyl amines are more basic than ammonia, which are more basic than aryl amines. So directly this will not be there, children. You must apply into different examples. Let us see few more. See, children, one more question we are having here. The correct order of basicity of the following compounds. Option 1, they had given this method, this is the line representation. Some children are still being confusing, in a state of confusion. There is nothing but ethanamine. What is the name called as that? Ethanamine. Option B. Option B is given as like this. What is this one? CH3, CH, double bond, NH. It is called as the ethanamine. Ethanamine. It is called as the ethylamine. Ethyl or ethylamine. Ethylamine. And now here, among these two bonds, you see which is more basic. Already in the last point also raising this one. Nitrogen is having lone pair. Any alkyl group when present, it gives the electrons to the nitrogen. Instead of the alkyl group, once you have any double bond to the nitrogen, it still makes the nitrogen to be more basic. Because this is a nucleophilic center. And it favors for the nitrogen lone pairs to be readily donated. So among these two means like alkyl means as if we have a single bond and a double bond, the double bond containing carbon nitrogen will be more basic. Okay. So among the first and second option, we are very clear. Second option is more basic than the first one. Second option is more basic than the first one. Now coming to the third one. You can see here a different type. The line represents CH3, NH, and NH2 is there, no children. This is in an open form. CH3, C, NH2, double bond, NH. This is the structure. If you see the fourth one, I am writing the complete structure. NH2, C, NH2, double bond, NH2. Now compare these two. Which two? The third one and the fourth one. In the third one, how many nitrogens are present, children? 2 nitrogens are present. In the fourth one, how many nitrogens are present? 1, 2, and 3. So obviously the point is like when the number of nitrogens increases, the lone pairs will be showing more basic nature. So among 3 and 4, we will say the fourth being having 3 nitrogens with 3 lone pairs, and the double bond nitrogen will have more basic nature. So what I will bring is the fourth is more basic than the 3. Whereas the 3 and 2, once you compare, here there is only 1 nitrogen and 1 lone pair. Here there are 2 nitrogens. So 3 is more basic than 2. That is more basic than 1. The main thing you must observe is double bond nitrogen containing lone pair is more basic. So find out this option where we have option 1, or the A can speak. 1 is less than 2, 2 is less than 3, 3 is less than 4. So keep this point in new version of application. Mostly they will be asking JEE mains this type of questions. See this question, children, here. The correct increasing order of basic strength for the following compounds is. The correct increasing order of basic strength means least basic will come first, more basic will go to the last in the given set of order. Only 3 are given, 1, 2 and 3. Once you see the first one, it is called as the ethanamine. Diethylamine we can speak. Diethylamine also we can speak in the common term. It is an alkylamine. What is the first option speaking with them? It is speaking with the alkylamine. It is an alkylamine. And the second one, once you speak, it is having a ring compound nitrogen at the center. Do you remember the starting we brought? The cyclic, like heterocyclic compounds. Heterocyclic compounds were more basic than the alkyl amines. Heterocyclic compounds are more basic than the alkyl amines. So among the second and first we came to the second is more basic. But now coming to the third. Or the third one is, we know in these two cases lone pairs are freely available. But in this case, lone pair is involved in resonance with the benzene. Lone pair is involved in resonance with the benzene. So what we can speak, this is less basic than the remaining two. Uridine is less basic than the remaining two. So how will be the order? 3, 3 less than 3 less than 1, that is less than 2. 3 less than 1, that is less than 1. Why? You are able to understand, right? That difference you don't forget. Alkyl amines are more basic than amine, everyone knows. But once we compare alkyl amines with heterocyclic compounds, they are more basic. That is the rule to be studied. Write down, children. Wherever you are writing, you write the explanation also. Thank you, children. In the next session, we will see the remaining chemical properties. Last point I would like to recall here, the basic nature of these amines. The basic nature of these amines, once you see, in the textbook there is one tabulated data. Basic nature of these amines is generally given as, in the form of the pKb values. Okay, or that is equal to minus log Kb. So the smaller the value, smaller the pKb value, the compound will be more basic. Larger the log Kb value, compound will be less basic. So these are inversely proportional. This tabulated data you must read from the textbook. I am not writing the tabulated data now. So you please keep in mind, we have discussed only one chemical property today. That's called as with the basic nature. In the next session, we will deal with the remaining points. Thank you, children.